Welcome friends. Lesson number 2, Pythagoras Theorem. Problem set 2. In last lecture we have solved question number 2 to question number 10, and today we are going to solve the question number 11 to question number 18. Now question number 11, in triangle ABC, angle BAC is equal to 90 degree, segment BL and segment CM are medians of triangle ABC. Then prove that 4 in bracket BL square plus CM square is equal to 5B square, 5BC square. Now let's see. In triangle ABC, BL is a median, then point L is midpoint of side AC. Therefore we can apply Apollinaire theorem for this triangle. So write, in triangle ABC, segment BL is median it is given. Therefore L is midpoint of side AC. L is midpoint of side AC. Therefore we apply Apollinaire theorem for this triangle. BC square plus AB square, BC square plus AB square is equal to 2BL square plus 2AL square, 2BL square plus 2AL square. Reason is Apollinaire theorem. Therefore BC square plus AB square is equal to 2BL square plus 2 in bracket. Now L is a half of AC. Therefore in bracket half into AC bracket square. Reason is L is midpoint of AC. Therefore BC square plus AB square is equal to 2BL square plus 1 upon 2 AC square will be 1 upon 4 AC square, and into 2 it will be 1 upon 2 AC square. Therefore now multiply both sides by 2. Therefore 2BC square plus 2AB square is equal to 4BL square plus AC square. Multiplying both sides by 2. Therefore 4BL square is equal to 2 into BC square plus 2 into AB square minus AC square. This is equation number 1. Now in triangle ABC, M is a midpoint of AB. There M is midpoint of AB because CM is a median. Therefore we can apply Apollinaire theorem for this triangle. Therefore once again, in triangle ABC, segment CM is median. It is given Therefore, M is midpoint of AB. Therefore, apply Apollinaire theorem. BC square plus AC square, BC square plus AC square is equal to BC square plus AC square is equal to 2 into CM square, 2 into CM square plus 2 into BM square. Reason is Apollinaire theorem. Therefore, BC square plus AC square is equal to 2CM square plus 2 in bracket BM. BM is half of AB. Therefore, we write 1/2 into AB bracket square. Reason is M is midpoint of AB. Therefore, BC square plus AC square is equal to 2 into CM square plus 1/2 AB square is 1/4 AB square into 2, that will be 1/2 AB square. Multiply both sides by 2. Therefore, 2 BC square plus 2 AC square is equal to 4 CM square plus AB square. Multiplying both sides by 2. Therefore, 4 CM square, this M is capital, 4 CM square is equal to 2 into BC square plus 2 into AC square minus AB square. This is equation number 2. Now add equations 1 and 2. Equation 1, 4BL square. Here write, adding equations 1 and 2. Therefore, 4BL square in equation 1 plus 4 CM square, 4 CM square is equal to, here is a 2 BC square plus 2 AB square, 2 BC square plus 2 AB square minus AC square plus 2 BC square plus 2 AC square minus AB square is equal to, therefore 4BL square plus 4 CM square is equal to 2 BC square plus 2 BC square is a 4 BC square plus 2 AB square and minus AB square is plus AB square minus AC square plus 2AC square is plus AC square. This is equation number 3. Now in triangle ABC, AB square plus AC square is equal to BC square. AB square plus AC square is equal to BC square. Pythagoras theorem. This is equation number 4. AB square plus AC square. AB square plus AC square is equal to BC square. Pythagoras theorem. Therefore, 4BL square plus 4CM square is equal to 4BC square, and this AB square plus AC square will be BC square. Reason is from 3 and 4. Therefore, take 4 common. 4 in bracket BL square plus CM square is equal to 4BC square plus BC square, that is a 5BC square. Thus 4 in bracket BL square plus CM square is equal to 5BC square is proved. Example number 12. Sum of the squares of adjacent sides of parallelogram is 130 centimeter square, and the length of one of its diagonal is 14 centimeter. Find the length of other diagonal. Let PQRS is a parallelogram and the diagonal PR and QS intersect at point A. Let QS is equal to 14 centimeter. Therefore, QA is equal to 7 centimeter. Since diagonals of parallelogram bisect each other, therefore this QA will be 7 centimeter and A is the midpoint of a QS. So, for triangle PQS, A is the midpoint of a QS. So, we can apply Apollinaire theorem for this triangle. Let's solve this example. Let quadrilateral PQRS is parallelogram diagonals PR and QS intersects at point A. Therefore, and here we have given, let QS is equal to 14 centimeter. Therefore, QA is equal to 1/2 into QS. Reason is diagonals of parallelogram bisect each other. Therefore, QA is equal to 1/2 into 14. Therefore, QA is equal to 7 centimeter. This QA is 7 centimeter. Let PQ square plus PS square is equal to 130. PQ square plus PS square is equal to 130. Therefore, in triangle PQS, A is midpoint of side QS. Therefore, we use Apollinaire theorem, PQ square plus PS square. PQ square plus PS square is equal to 2 into PA square plus 2 into QA square. Reason is Apollinaire theorem. Therefore, PQ square plus PS square is 130. Therefore, 130 is equal to 2 into PA square plus 2 into QA is 7 square. Divide both sides by 2. 130 divided by 2 is 65 is equal to PA square plus 7 square. Dividing both sides, by 2. Therefore, PA square is equal to 65 and 7 square is 49. So 65 minus 49 is 16. Therefore, PA is equal to 4. Taking square root on both sides. Now we have to find the another diagonal, that is a PR. So PR is equal to 2 into PA. Reason is A is midpoint of PR. Therefore, PR is equal to 2 into 4 is equal to 8 centimeter. Therefore, length of other diagonal is equal to 8 centimeter. Question number 13. In triangle ABC, AD perpendicular to segment BC, DB is equal to 3 into CD. Prove that 2AB square is equal to 2AC square plus BC square. Now, in triangle ABC, segment AD perpendicular segment BC, it is given. Also, DB is equal to 3CD, it is also given. Therefore, angle ADC is equal to angle ADB is equal to 90 degree. Suppose this is equation number 1, this is equation 2, this is from equation 1. Now, in triangle ADC, in right angled triangle ADC, use Pythagoras theorem. AC square is equal to AD square plus CD square. Therefore, AD square is equal to AC square minus CD square. This is equation number 3. Now, in triangle, this is here reason we have to write Pythagoras theorem. Now consider triangle ADB. This angle is right angle, therefore here we also use Pythagoras theorem. So in right angled triangle ADB, this is hypotenuse, AB square is equal to AD square plus DB square. This is according to Pythagoras theorem. Now let's see. AD square is equal to AC square minus CD square and DB is equal to 3CD. So from equations 2 and 3, therefore AB square is equal to, we write AD square is equal to AC square minus CD square plus DB is equal to 3CD square. Reason is from 2 and 3. Therefore AB square is equal to AC square minus CD square plus 3CD square is 9CD square. Therefore AB square is equal to AC square plus 8CD square. This is equation number 4. Now in figure, BC is equal to CD plus BD. BC is equal to CD plus BD. Reason is C dash D dash B, but BD is equal to 3CD. Therefore BC is equal to CD plus 3CD. BD is equal to 3CD. This is from equation 1. Therefore BC is equal to CD plus 3CD is a 4CD. Therefore CD is equal to 1/4 into BC. This is equation number 5. Now put equation 5 in equation 4. So we write equation 4 as AB square is equal to AC square plus 8 into that CD is a 1/4 BC. 1/4 BC bracket square. This reason is from 4 and 5. Equations 4 and 5. Therefore AB square is equal to AC square plus 8 into 1/16 into BC square. 1/4 BC square is 1/16 BC square. Therefore AB square is equal to AC square plus 8 into 2 is 16, that is 1/2 BC square. Multiply both sides of this equation by 2. Therefore 2AB square is equal to 2AC square plus BC square. Multiplying both sides by 2. Therefore 2AB square is equal to 2AC square plus BC square is proved. Example number 14. In an isosceles triangle, length of congruent sides is 13 cm and base is a 10 cm. Find the distance between the vertex opposite to the base and centroid. This is a triangle ABC, isosceles triangle, in which two sides AB and AC are equal to 13 centimeter and side BC is the base, it is a 10 centimeter. G is a centroid and we have to find the distance between this centroid and the vertex A opposite to side BC, that is we have to find the distance AG here. Now AD is the median of this triangle, therefore D is the midpoint, therefore BD is equal to half of BC, that is BD is equal to half into 10 centimeter, that is half into 10 is equal to 5 centimeter. Now in triangle ABC, D is the midpoint of BC, therefore we can apply Apollinaire theorem for this triangle. So Apollinaire theorem will be AB square plus AC square is equal to 2 into AD square plus 2 into DC square. Now put the values. AB is a 13 square plus AC is 13 square plus 13 square is equal to 2 into AD square, and DC is equal to BC here. So value of BC and DC are same, so DC is equal to 5 also. So 13 square plus 13 square, 2 into 13 square is equal to 2 AD square plus 2 into 5 square. Divide both sides by 2, that is this 2 and this 2 will get cancelled, therefore 13 square is equal to AD square plus 5 square. Therefore AD square is equal to 13 square is a 169 and 5 square is a 25. 169 minus 25 is 144. So AD is equal to square root of 144. AD is equal to 12 centimeter. Now we know that this centroid divides the median in the ratio 2:1, that is AG upon GD is equal to 2 upon 1. So by invertendo GD upon AG is equal to 1 upon 2. Now GD plus AG upon AG is equal to 1 plus 2 upon 2, that is componendo, that is GD plus AG. GD plus AG will be AD. So AD upon AG is equal to 1 plus 2 is a 3 upon 2. Now AD upon AG is equal to 3 upon 2. But we have given AD is equal to 15, AD is equal to 12. We have given, so 12 upon AG is equal to 3 upon 2. So AG is equal to 12 into 2 upon 3. AG is equal to 8 centimeter. So distance between the vertex opposite to the base and centroid is a 8 centimeter. Here we have AD 12 centimeter. So AD upon AG. AD 12 upon AG is equal to 3 upon 2. So AG is equal to 12 into 2 cross multiplication upon 3. 3 4 are 12. 4 into 2 is 8 centimeter. AG is equal to 8 centimeter. Therefore distance between the vertex opposite to the base, this vertex A opposite to the base B, BC, and the centroid G is a AG is equal to 8 centimeter. Example number 15. In trapezium ABCD, segment AB parallel segment DC, segment BD perpendicular segment AD, segment AC perpendicular segment BC. AD is equal to 15, BC is equal to 15, and this AB is equal to 25. AB is equal to 25. Find area of quadrilateral ABCD. Now construction. Draw segment DM perpendicular to segment AB such that A dash M dash B, also segment CN perpendicular to segment AB such that A dash N dash B. Now consider triangle ACB. In this triangle, angle C is equal to 90 degree, BC is equal to 15 and AB is equal to 25. Therefore, by applying Pythagoras theorem, we can find the AC. So, in triangle ACB, angle ACB is equal to 90 degree. It is given. Side opposite to right angle is hypotenuse. Therefore, AB square is equal to AC square plus BC square. Pythagoras theorem. We have to find AC. Therefore, AC square is equal to AB square minus BC square. AB is a 25 square minus BC is a 15 square is equal to 625 minus 225. Therefore, AC square is equal to 625 minus 225 is 400. Therefore, AC is equal to 20. This is our taking square root on both sides. So, value of AC will be 20 here. Now, in triangle ACB, we can find area of this triangle as 1/2 BC into AC in this way. Then we can find the area of this triangle also by area is equal to 1/2 base AB, 1/2 AB into CN. From this we can find out CN. Now in triangle ACB or direct area of a triangle ACB is equal to 1/2 into base BC into height AC is equal to 1/2 into BC is a 15 and AC is 20. 10. Therefore, area of a triangle ACB is equal to 15 into 10, 150 square units. But area of a triangle ACB is equal to 1/2 into AB into CN. If we take AB as a base and CN as a height, then area of a triangle ACB is equal to half into AB into CN. Therefore, this area is a 150 is equal to 1/2 into AB into CN. Therefore, 150 is equal to 1/2 into AB is 25 into CN. Therefore, 25 CN is equal to 150 into 2. Therefore, CN is equal to 150 into 2 upon 25. Therefore, CN is equal to 25. 6 are 156. 6 into 2 is 12 units. Here CN we get 12 units. This value we get 12. Similarly, we can find the value of a dm as a 12. Similarly, dm is equal to 12 units. Now consider a triangle C and B in right angled triangle C and B. Hypotenuse is a BC. BC square is equal to CN square plus NB square. Pythagoras theorem. Therefore, BC square is a 15 square is equal to Cn. Value of Cn is a 12. 12 square plus NB square. Therefore, NB square is equal to 15 square is 225 minus 144. 225 minus 144. It will be 15 minus 5 minus 4 is a 1 and 12 minus 8 4 is a 8. It will be 18. So NB square is equal to 81. Therefore NB is equal to 9 units here. NB is equal to, we get 9. Similarly, AM is equal to 9. This AM we can find 9. Let's find the value of MN now. So AB is equal to AM plus MN plus NB. Reason is A dash, M dash, N dash, B, and AB is a 25 is equal to AM 9 plus MN plus NB is also 9. Therefore, MN is equal to 25 minus 18 is equal to 7 units. This MN will be 7 units. 7 units. Now, DM perpendicular to AB and CN perpendicular to AB and DC parallel to AB. Therefore, DM NC is a rectangle. Segment DM perpendicular segment AB. Segment CN perpendicular segment AB. And DC parallel AB. Therefore, quadrilateral DMNC is rectangle. Quadrilateral DMNC is rectangle. So MN is equal to 7. So DC is equal to 7. Therefore, MN is equal to DC is equal to 7 units. So DC is a 7 units. Now we can find the area of a trapezium. So area of a quadrilateral ABCD is equal to, it is a trapezium. So area of trapezium is 1 upon 2 into sum of parallel sides into height is equal to 1 upon 2 into sum of parallel sides into height is equal to 1 upon 2 into sum of parallel sides, that is AB plus DC, AB 25 plus 7, 25 plus 7 into height is CM, that is a 12, is equal to 25 plus 7 is a 32, and this 12 divided by 2 is a 6. Therefore, area of a quadrilateral ABCD is equal to 32 into 6. 6 to the 12, 6 3 the 18 plus 1, 192 square units. 192 square units. Question number 16. In the figure, triangle PQR is equilateral triangle. Point S is on segment QR such that QS is equal to 1 upon 3 into QR. Prove that 9 PS square is equal to 7 PQ square. Now here is a construction. Segment PQ perpendicular to segment QR. Construction. Draw segment PT perpendicular side QR, Q dash, S dash, T dash are. Now in this triangle PTQ, this angle is 90 degree, this angle is 60 degree, therefore this remaining angle will be 30 degree. So in triangle PTQ, angle PTQ is equal to 90 degree. Reason is construction. Angle PQT is equal to 60 degree. Angle PQT is equal to 60 degree. Angle of equilateral triangle, therefore angle QPT is equal to 30 degree. This angle is now 30 degree. Remaining angle of triangle. So triangle PTQ is 30 degree, 60 degree, 90 degree triangle. So we can find the value of a PT. PT is a side opposite to 60 degree. PT is a side opposite to 60 degree. We know that side opposite to 60 degree is root 3 upon 2 times of hypotenuse. Here hypotenuse is PQ. Therefore PT is equal to root 3 upon 2 into PQ. And this side QT is opposite to this angle. This angle is 30 degree. Side opposite to 30 degree is half of hypotenuse. And QT is equal to 1 upon 2 into PQ. Reason for this is 30 degree. 60 degree, 90 degree triangle. Theorem. Let this is equation number 1. Now here we have given Qs is equal to 1 upon 3 into Qr. This is a given. Also PQ is equal to QR. PQ is equal to QR. Equation number 3. Sides of equilateral triangle. Sides of equilateral triangle. Now here QT is equal to 1 upon 2 into PQ. QT is equal to 1 upon 2 into PQ. QT is equal to 1 upon 2 into PQ, but QT is QS plus ST. Therefore, QS plus ST is equal to 1 upon 2 into PQ. Reason is Q dash S dash T. Now let's see, QS is equal to 1 upon 3 into QR. QS is 1 upon 3 into QR plus ST is equal to 1 upon 2 into PQ. This is from equation 2. But QR is equal to PQ. Therefore, 1 upon 3 into PQ plus ST is equal to 1 upon 2 into PQ. This is from equation 3. QR is equal to PQ. Put QR is equal to PQ. Therefore, ST is equal to 1 upon 2 PQ minus 1 upon 3 PQ is equal to PQ upon 2 minus PQ upon 3. So by cross multiplication, 3 PQ minus 2 PQ upon 6. Therefore, ST is equal to 3 PQ minus 2 PQ is a PQ. PQ upon 6. This is equation number 4. Now consider a triangle PTS. In this triangle, angle PTS is equal to 90 degree. In triangle PTS, angle PTS is equal to 90 degree. It is a given. Therefore, we can apply Pythagoras theorem for this triangle. So PS square is equal to PS square. PS is hypotenuse, is equal to PT square plus ST square. So PS square is equal to value of PT is root 3 upon 2 into PQ. Root 3 upon 2 into PQ bracket square, and value of ST is PQ upon 6. PQ upon 6 bracket square. This is from equations 1 and 4. This is from equations 1. From equation 1, PT is equal to root 3 upon 2 PQ. So PT is equal to root 3 upon 2 PQ. From equation 4, ST is equal to PQ upon 6. Therefore, PS square is equal to root 3 square is a 3. 3 upon 4 PQ square plus PQ square upon 6 square is a 36. Therefore P S square is equal to, multiply this 4 by 9 and 3 by 9, 9 3 are 27 PQ square upon 9 4 are 36 plus PQ square upon 36. Therefore PS square is equal to 27 PQ square, and 1 PQ square will be 28 PQ square upon 36. Therefore PS square is equal to, divide this 28 and 36 by 4. So 4 sevens are 28. So 7 PQ square, and 36 divided by 4 is 9. Therefore 9 into PS square, 9 into PS square is equal to 7 into PQ square is proved here. Question number 17. Segment PM is median of triangle PQR. PQ is equal to 40, PR is equal to 42, and PM is equal to 29. Find QR. Let's solve this example. In triangle PQR, segment PM is a median. Therefore M is midpoint of QR. This is given. So we can apply Apollinaire theorem for this triangle. Apollinaire theorem, PQ square plus PR square is equal to 2 into PM square plus 2 into QM square. So PQ square plus PR square is equal to 2 into PM square plus 2 into QM square. PQ is a 40 square plus PR is a 42 square is equal to 2 into 29 square plus 2 into QM square. 40 square 1600. Now 42 square, 42 into 42. 2 into 2 4, 2 into 4 is 8. 4 into 2 8, and 4 4 are 16. 8 plus 8 16. 1764. 1764 is equal to 2 into 29 square is 841 plus 2 into QM square. Now this 1600 plus 1764, that is a 4 6, it will be 3364 is equal to 2 into 841 plus 2 into QM square. Now divide both sides by 2. So if we divide this, 1, 2 6 are 12, 2 8 are 16, and 2 2 are 4. So 1682 is equal to 841 plus QM square. And reason is, dividing both sides by 2, therefore QM square is equal to 1682 minus 841. Therefore Qm square is equal to 1682 minus 841. 1, 4 and 8. That will also 841. Therefore Qm is equal to square root of 841. Therefore Qm is equal to square root of 841 is a 29. So Qm is equal to 29. We have to find QR. Now QR is equal to 2 into Qm. Reason is M is midpoint of QR. Therefore QR is equal to 2 into 29. QR is equal to 58. We get QR is equal to 58 units. Example number 18. Segment AM is median of triangle ABC. If AB is equal to 22, AC is equal to 34, BC is equal to 24. Find AM. Now let's solve this example. In triangle ABC, AM is a median. Therefore M is midpoint of BC. This is a given. Therefore BM is equal to 1 upon 2 into BC is equal to 1 upon 2 into 24 is equal to 12. BM is equal to 12 here. And we have to find AM. So we can apply Apollinaire theorem for this triangle. So this theorem is a AB square plus AC square. AB square plus AC square is equal to 2 into AM square plus 2 into BM square. Apollinaire theorem. Now AB, that is a 22 square plus AC 34 square is equal to 2 into AM square. That AM is to find here, plus 2 into 12 square. 22 square is 484. 34 square, 34 into 34. 4 4s are 16, 4 3s are 12, plus 1 is 13, 4 3s are 12, 3 3s are 9, 9 plus 1 is 10. That will be 1156 is equal to 2 into AM square plus 2 into 12 square is a 144. Now 1156 plus 484, 6 plus 4, 10, 8 plus 9, 9 plus 5 is a 14. This will be 1640. 1640 is equal to 2 AM square plus 2 into 144. Now divide both sides by 2. So divide 1640 by 2. That will be 8. So 820. 820 is equal to AM square plus 144. Dividing both sides by 2. Now AM square is equal to 820 minus 144. 820 minus 144, this is a 6, carry 1. 12 minus 5 is a 7. So therefore am square is equal to 676. Therefore am is equal to square root of 676. Therefore am is equal to 26. Square root of 676 is 26 units.